Hi, I am Arib. You are watching my YouTube channel. Star versus Delta question and answers. Question 1. What are star and delta transformations in electrical circuits? Answer. Star and delta transformations are methods used to convert a complex electrical circuit from one configuration to another, either from star, gamma to delta, delta, or from delta, delta to star, gamma. Question 2. What is the main purpose of using star and delta transformations? Answer. The main purpose of using star and delta transformations is to simplify complex electrical circuits, making them easier to analyze and calculate. Question 3. Can star and delta transformations be used in both AC and DC circuits? Answer. Yes, star and delta transformations can be used in both AC and DC circuits. The principles and equations remain the same regardless of the circuit type. Question 4. Can star and delta transformations be used for circuits with capacitance or inductance elements? Answer. Yes, star and delta transformations can be applied to circuits with capacitance or inductance elements as long as the circuit configuration remains the same. Question 5. What is the relationship between the current flowing in a star configuration and the current flowing? Answer. The current flowing in a star configuration is divided among the branches, while the current flowing in a delta configuration is the sum of the currents in each branch. Question 6. How would you calculate the total power in a circuit after applying a star or delta transformation? Answer. After applying a star or delta transformation, the total power in a circuit can be calculated by summing the power in each individual component or branch. Question 7. What happens to the voltage across each component when a circuit undergoes a star to delta transform? Answer. The voltage across each component remains the same when a circuit undergoes a star to delta transformation. Question 8. What are the conditions for a star-delta transformation to be valid? Answer. The conditions for a star-delta transformation to be valid include having a balanced network with equal resistances or impedances in each branch. Question 9. In which scenarios are star and delta transformations most commonly applied? Answer. Star and delta transformations are commonly applied in power systems analysis, balanced three-phase circuits, and network analysis. Question 10. How does star-to-delta transformation affect the total resistance of a circuit? Answer. Star-to-delta transformation maintains the total resistance of the circuit as it simply reconfigures the resistors without changing their overall sum. Question 11. What are some practical applications of star and delta configurations in electrical engineering? Answer. Practical applications include power generation, distribution transformers, motor control systems, and industrial power systems. Question 12. Can star-delta transformations be reversed? Answer. Yes. Star-delta transformations can be reversed by applying the appropriate formulas to convert from delta to star or star to delta configurations. Question 13. Can star-delta transformations be applied to unbalanced circuits? Answer. Star-delta transformations are primarily applicable to balanced circuits. While they can be extended to some unbalanced cases, the results may not accurately represent the original circuit.